So this final example is another one of these, how many terms in the series are required to give a sum of whatever. And this is going to be a question where we're using the sum to n terms formula in a slightly unusual way. Or maybe not unusual, different way. Different to what we would do in most problems. What we are told here is what the sum has to be. Okay. And we're told the first term, we can work out the first term, we can work out the common ratio. We're asked how many terms are needed, so we're going to be determining the n here. And a question like this will have to be kind of rigged. They will have to give you the thing that actually is the sum, and they'll be trying to set it up so the process isn't too laborious for you. So let's have a look here. A is the first term, that's going to be 2. The common ratio in this thing, if we divide any two subsequent terms, we'll see that the common ratio is 3. And there is also 3. So I'm going to get that 2 outside of 3 to the n minus 1 on 2. These will cancel. And I'm left with 3 to the n minus 1. Okay, tidying up here, add 1 to both sides. 729 equals 3 to the n. Now, as I said before, this has to be rigged to be doable. It has to be determined. Someone will have picked something which is a power of 3 to go here. Without having logarithms, there's no other way of solving this. You have to be able to work it out kind of manually. Okay. So if we were to take 3 to the power of 4, that would be 81. Okay. So if you, what you can do here is just trial and error. So if you triple that, you'd get 3 to the 5, which is 243. Well, that's not big enough yet, so I'll times by 3 again. 3 to the 6, hey, that's 729. So the answer here, the solution to these kinds of problems will always be some kind of power of whatever the base is here. So here I've trial and errored and gone, 3 to the 6, well that's 729. So 3 to the n is 3 to the 6, which means that, well, n must be equal to 6. So the answer to my question at the start was, how many terms are needed? Well, I need 6 terms to get a sum of 728.